All right, guys, here we go. My little babies. We have a lot of problems to do here. 30, 60, 90s, 45, 45, 90s, Pythagorean theorem, all kinds of good stuff. First question here, and ask us to use the four triple families. I called them families. These are the four base triples. It says to put them in order from smallest to biggest. The smallest ones are 3, 4, 5. 5, 12, 13 is next. 7, 24, 25 is next. And 8, 15, 17 is last. And for bonus points, 9, 40, 41, if you remember that one. But you gotta know these four, my friends. Simplifying radicals, remember that root 48 times root 48 is the same as root 48 squared, which cancels each other out, making it just whole number 48. Let's get it. Next question. Every time you do a problem like this, whether it's division or multiplication, it is always easiest to look for common factors. We'll go ahead and do the 3 times 2. Whole number 3 times whole number 2 is 6. And then root 10 is the same as root 5 times root 2. Root 12 is the same as root 6 times root 2. There is a common factor 2, which becomes whole number 2. Root 2 times root 2 is whole number 2. So those are out. And we're left with 5 times 6, which is root 30. Remember, we always check this number here. Are there any more perfect square factors? What are the perfect squares? I'm not going to do this every time, but you list the perfect squares. Do any of these numbers go into 30? The answer is no. So we know that that is complete. So the answer would be 6 times 2 is 12, and we leave it as root 30. Next question, 45, 45, 90 rules. Just as a reminder, what it looks like, every single 45, 45, 90 triangle reduces to these three numbers. Oh, that's not it. These three numbers. 1, 1, root 2. Every single one. So we know that in this case that the hypotenuse is 12 root 6. That means the leg times root 2 had to equal that. Something times root 2 has to equal 12 root 6. So how do you get rid of times root 2? You divide by root 2. So if we divide both sides by the square root of 2, we would be left with 12 root 3. Root 6 divided by root 2 is just root 3. They cancel out. Ooh, so that is our answer, 12 root 3. So if you have the hypotenuse, how do you get smaller? You divide by the square root of 2. If you have the leg, how do you get bigger? You multiply by the square root of 2. Those are the only two moves you will make on a 45, 45, 90. 8 divided by root 7. Remember, you cannot have a radical in the denominator. If I multiply the bottom by root 7 to get rid of the radical, I have to also multiply the top by root 7. Why? Because we need to keep the number the same. What is root 7 divided by root 7? It's just the number 1. So we're multiplying by the number 1, which means our number won't change, but it'll look different. Quick reminder of why that is. Remember the number's 2/3? We did this in class. If I multiply the top and bottom by 4, for instance, I would have 8 over 12. This is a little easier to conceptualize, but 8/12 and 2/3 are the exact same number because we multiplied by the number 1. 4 divided by 4 is just the number 1. So when you do that, you don't change value. Well, that's true here as well. So that's why this works the way it does. So you multiply the top and bottom by root 7 to get the radical out of the denominator. Next question. Determine if the following could be side lengths of a triangle. So if it's a triangle, that means when you add the two smallest sides, it has to be bigger than the third side. So we'll just go through the list. We're going to add the two smallest numbers. So 6 plus 8 is 14, and that is bigger than 12. Over here, 5 plus 1 is 6, and that is not bigger than 6. Here we have 3 plus 2 is 5. That is bigger than 3. Here we have 3 plus 4 is 7. That is not bigger than 7. Here we have 20 plus 24. That is 44. That is bigger than 40. And here we have 55 plus 22. That is not bigger than 88. So yes, no, yes, no, yes, no. Woo! We're going to get to it later, but this is it even a triangle? Later we're going to figure out, well, if it is a triangle, is it right, acute, or obtuse? So that's a different process. We'll get to that in a minute. All right, right triangle. We don't have a 30, we don't have a 60, we don't have a 45, we just have two numbers. So if you have two numbers, your best first move is to reduce. I know 3 goes into this. Let's see, 24 divided by 3 would be 8. 51 divided by 3 would be 17. If you know your triples, you know that that's a 15 there. So 15 times 3 would give you 45. So reduce and do Pythagorean theorem on the small triangle. If it's one of your triples, you should be quick to retrieve those numbers. 8, 15, 17 is one you need to know. And speaking of triples, see if you can do this. Make sure you're trying this stuff, guys. Don't just watch the video. Make sure you're trying these questions. But this would be a 3, 4, 5. This is a 5, 12, 13. 7, 24, 25. And 8, 15, 17. Let's go. Simplify the following. So reduce if you can. Nothing here reduces. You cannot reduce a whole number with a radigan. Can't do it. But we can go ahead and multiply the top and bottom by root 15. That gives us 9 root 15 over whole number 15. Now we look again. Can you simplify the radical? Can you reduce? Yes. 9 and 15 reduces to 3/5. So that is 3 root 15 over 5. So to get rid of the radical, you have to swing it to the top. My hope is you can go from this straight to this in your head. That is the goal. That is something you should be actively trying to do. What ends up happening every time, so to look at it one more time, is if you have a radical on bottom, you get a radical version of it on top and a whole number version of it on bottom, and then you reduce if you need to. 30, 60, 90 rules. So if I draw a 30, 60, 90, pay close attention to the angles. If this is my 30 and this is my 90, the side across from 30 is what we call the short leg. The side across from 60 is the long leg, and then you have the hypotenuse. Every single 30, 60, 90 reduces to this triangle right here. So keeping that in mind, figure out what you got. Well, we have the side across from 60, so we know that this is the long leg. The long leg is associated with the number root 3. That means that 6 is equal to the short leg times root 3. So we have to divide off the root 3. So this is what we were just doing a second ago. What ends up happening is you get a radical version of root 3 on top and a whole number on bottom. And then 6 divided by 3. Uh-oh. That's 2 root 3. Maybe I wrote down the wrong. Oh, x is the hypotenuse. Okay. So we're not actually looking for the short leg, but all roads go through the short leg. Once you have the short leg, the hypotenuse equals 2 times the short leg. So 2 times this number, so times 2 would get you 4 root 3 at the end of the day. Yes. 2 times the short leg. 2 times the short leg to get the hypotenuse. Simplify the radical. The way I show you guys in class is pull out perfect squares. So what are the possible options? 4, 9, 16, 25, 36, and then 49 is too big. Do any of these go into 48? Well, a couple of them do. I'll show you both ways. First, you could do the square root of 16 times the square root of 3. Why would we do that? Well, the square root of 16 is 4, leaving you with a root 3. And that would be the answer. Your other option is, what if you didn't realize 16 went into it, is you could have pulled out a 4, and that would be 4 times 12. So you would have 2 root 12. The issue is you would not be done. Root 12, think about your list, 3, 9, well, that's the only options. Not wait, 3 and 9. 4 and 9. Well, 4 goes into 12. So that would be root 4 times root 3. And root 4 is like the number 2. So this would be 4 root 3 again. It doesn't matter which way you pick. But the bigger perfect square will be the faster way to go every time. So your answer here is 4 root 3. Next question. Pythagorean theorem, it's just a triple. This is a 5, 12, 13. If you know your triples, that's a very quick question. Another Pythagorean theorem question. We reduce first. So what can we pull out? 15 divided by 3 would be 5. 39 divided by 3 would be 13. This is the same triple we just did, so this would have to be 12 times 3 would give you 36. 12 times 3 gets you 36. Boom. Got it. 30, 60, 90 rules. Here's a 60. So what do we have? We have the side across from 90. That is the hypotenuse. If you remember your 30, 60, 90 rules, is that the short leg times 2 equals the hypotenuse. So you need to divide the 2 off. So the side across from 30 will be 4 root 21, but they want the long leg. Remember that the long leg equals the short leg times the square root of 3. So the long leg is going to equal 4 root 21 times the square root of 3. Remember, when you're multiplying, I find it better to pull out a common factor if possible. There's a common factor of 3 here. Why? What is root 3 times root 3? That is whole number 3. Don't forget the 4 in front. So this would be 12 root 7. So I had to do 4 root 21 times root 3 and simplify that. Oop, our triples again. 3, 4, 5 is a triple. 5, 12, 13 is a triple. 7, 24, 25. And 8, 15, 17. Get them down, my friends. Keep trying to do it from memory. Please keep trying to do it from memory. All right, we have a Pythagorean theorem question. So first thing we do, Pythagorean theorem, is we draw a smaller triangle and reduce. We can divide by 6 and get 4, divide by 6 and get 5. So is this 3? No. If it's a 3, 4, 5, the longest number, 5, would have to be the hypotenuse. So while we have the numbers 4 and 5, the hypotenuse cannot be your 3. So we just need to do Pythagorean theorem on these smaller numbers. So this would be 16 plus 25. This would be the square root of 41. But we divided by 6 to get there, so we need to multiply this by 6 to go back home. So 6 root 41 is our answer. Perfect. All right, 30, 60, 90 rules. We have the with a long leg. So what do we know? We know that the short leg equals the long leg. Sorry, the short leg times root 3 equals the long leg. So the short leg times root 3 equals 6 root 3 on this question. If you have the long leg, how do you undo times root 3? You divide off the root 3, leaving you with 6. Well, that's not the question. We need the hypotenuse. Remember, the hypotenuse is equal to the short leg times 2. So 12 is the actual final answer here. 12. 30, 60, 90 rules. We have the side across from 30 this time. We want the side across from 60. Remember that the short leg times root 3 equals the long leg. So we have the short leg. 9 root 2 times root 3 equals the long leg. That's going to be 9 root 6. Yeah, we got to do a good job with that, guys. A real good job with that. All right, list these triples again. I love this. 3, 4, 5. 5, 12, 13, 7, 24, 25, 8, 15, 17. Come on now. Keep trying to do this from memory over and over again, guys. So we have two sides. I recognize this pattern. That's a 2 to 1 pattern. That means this is going to be root 3. This is a 30, 60, 90 all day. That's going to be 25 root 3. If you don't like that, could you redraw a smaller version of the triangle, reduced by a factor of 25? 50 divided by 25, 25 divided by 25. This would be 2 squared minus 1 squared, which is 4 minus 1, which is root 3. Boom, boom, boom. Told you. So if you recognize the pattern between a hypotenuse and a leg as being 2 to 1, you could quickly know that's a 30, 60, 90. But if you didn't, you can still do Pythagorean theorem. Just make sure you reduce first and then hit that Pythagorean theorem. And since we divided by 25, we had to multiply by 25. Oh, we just did this. Come on. 3, 4, 5, love it. 5, 12, 13, even better. 7, 24, 25, and then 8, 15, 17 all day. 45, 45, 90 rules. So remember on the 45, 45, 90, the long leg, there's no long leg. The short leg times root 2 equals the hypotenuse. That's the only rule here. So if we have the hypotenuse, we know that the short leg times root 2 equals 16. So we have to divide off the root 2. Well, we've practiced this. Remember, we're swinging the root 2 to the top. My hope is you can do this process in your head, but 8 root 2 is your final answer. Get to the point where you can do that in your head, guys. All the way, you should be able to go from this straight to this in your head as soon as possible. That means you're actively trying to do it. You're not hoping that you can do it. You're not saying, I can't do it, I can't do it. You're trying to do it every time until you can do it. Come on, team. 30, 60, 90 rules. So I didn't write them out earlier. I'm going to write them out real quick. Short leg times 2 is your hypotenuse. Short leg times root 3 is your long leg. So those are your only 2 rules here. So if you're working with hypotenuse, long leg, or short leg, there's a rule for you. What do we have here? Well, we have the long leg. So we're going to use that second rule. The short leg times root 3 equals the long leg. That means that the short leg times root 3 equals 9. So we have to divide by root 3. So we just did this. Try to do it in your head. This is what it looks like, but we got to get away from having to write it all out. So that's going to be 3 root 3 for the short leg. 9 divided by root 3 is 3 root 3. All right, simplify. Reduce by common factors when possible. 56 divided by, that is just 1 to 2 right there. So we have 10 over 3 root 2. And now it's like what we were doing earlier. Again, try to do this process in your head. What is root 2 times root 2? That's whole number 2, so we have a 6 on bottom. You're not done till you fully reduce. That would be 5 root 2 over 3 when you're all done. But that one reduced by a factor of 28. Always reduce first. Always. How often? All the time. All right, 30, 60, 90 rules. We have the side across from 60 this time. So remember that the short leg times root 3 equals the long leg. So the short leg times root 3 equals 15 because the long leg is what we have this time. So we have to divide off the root 3 to cancel it out. We've been practicing. We try real hard to do this in our head. This is what it looks like. So you would have 15 root 3 over whole number 3, which is 5 root 3. But that's the short leg, 5 root 3. How do we get the hypotenuse? Well, this equals the short leg times 2. Well, 5 root 3 times 2 would be 10 root 3. Nailed it. There we go. All right, is it right, acute, or obtuse? So remember, there's 2 things we got to check. First, is it even a triangle? That's the check to see if it's a triangle. And then, if it is a triangle, if it passes that test, we have 3 rules. There's 3 rules here. A squared, B squared, and C squared have 3 different things they can tell us. Well, if A squared plus B squared is equal, we've done that one for a long time. That's a right triangle. What if you have a right triangle? Okay. Well, what would happen if 90 degrees got bigger? Wouldn't the C value have to get bigger? Yes, we talked about this in the last video, but as C gets bigger, 90 gets bigger. So if C squared is bigger, it is obtuse, because if C gets bigger, 90 gets bigger, making it obtuse. What if that 90 degrees gets smaller? What has to happen? The opposite side has to get smaller. If C squared is smaller, that means 90 got smaller. That means we're working with an acute triangle. So first, is it even a triangle? No squaring there, guys. Second, if it is a triangle, what kind of triangle? Now we square the numbers. Now I told you on the quiz in our class, if it has irrational numbers, I won't make you check those. Those will work every time. But if they have all whole numbers, you do need to check them to see if it's even a triangle. So our first check is 6 plus 10 is 16. Is that enough to reach? Yes, it is a triangle. So once you've confirmed it's a triangle, then you start squaring numbers. 6 squared plus 10 squared would be 136. 12 squared is 144. Well, 144 is bigger, that means it is obtuse. If c squared is bigger, it's obtuse. 144 is greater than 136, obtuse. Here we need to square these numbers out. Remember that when you square something like this is like 5 root 3 times 5 root 3, or it's 5 squared times root 3 squared. These are all the same thing. So this is really 25 times 3, that is 75. Square this number, same idea. This would be 36 times 3, would be 108. And then 7 squared would be 49. So we square the numbers, and then we add the two smallest ones. So that would be 75 plus 49. 70 plus 40, 110 plus 14 would be 124. And then c squared is 108. Well, 124 is bigger. That means c squared is smaller. And if c squared is smaller, it has to be a cube. And then here, same idea. We need to start squaring numbers. 3 squared would be 9. 3 root 7 squared would be 9 times 7, 63. And 3 root 6 squared would be 9 times 6, 54. So we add the two smaller numbers. 9 plus 54 is 63. C squared is 63. That is the same. That is a right triangle. When a squared plus b squared equals c squared, it's going to be a right triangle. Oh, back to 30, 60, 90. I love it. So remember that the short leg times root 3 equals the long leg. We have the long leg. It's across from the 60. So we know that the short leg times root 3 has to equal 11. So we need to divide off the root 3. I am hoping that this is a process we can get really fast at. But we need to multiply root 3 to the top. That's 11 root 3 over whole number 3. But we need to get the hypotenuse, so we need to double that number, 22 root 3 over 3. Why not 22 over 6? Well, a lot of people would take the 11 root 3 over 3 times 2 and say that's 22 root 3 over 6. No. What is 22 over 6? That's just 11 over 3 again. No. We're multiplying by 2 over 1, not 2 over 2. I'm trying to double the number. If you multiply by 2 over 2, you're not doubling the number. You're just changing the number. So you're not even changing the number. You're just changing what it looks like. It's the same number. 22 over 6 and 11 over 3 are the same number. Please don't do that. All right, Pythagorean theorem. If you have two sides of a right triangle, you hit it with that Pythag. We can divide by 32 divided by 16 would be 2. 48 divided by 16 would be 3. Yeah, there we go. So 16 times 2, 16 times 3. So we pull out a GCF of 16, and we do Pythagorean theorem on the smaller numbers. Since we have two legs, we're going to be adding, 2 squared plus 3 squared. So that is 4 plus 9. That is the square root of 13. But we divided by 16 to get there, so we need to multiply by 16 to go back home. Yep, really hard to do that if you don't reduce first, guys. So if you don't have good strategies on the quiz, you're going to be in big trouble. Simplify. So we need to pull out the biggest perfect square. So 4, 9, 16, 25. 9 goes into 27. So we could rewrite this as root 9 times root 3. Well, what is root 9? That is whole number 3, leaving us with a root 3. Got it. Oop, another Pythagorean theorem question. So what am I going to do? I'm going to draw a smaller version of the triangle. Oh, gosh. I'm going to draw a smaller version of the triangle. Beautiful. I know 5 goes into them. Divided by 5 would be 7. Divided by 5. What is 125 divided by 5? Well, if I don't know that directly, I could do 100 divided by 5. I know that's 20. And 25 divided by 5, I know that's 5. 20 plus 5 would be 25. This is a triple. This is a 7, 24, 25. If you didn't know that, this might take a minute. We divided by 5 to get there, so we need to multiply by 5 to go back home. So that would be 120. Yep, 120. 24 times 5 is 120. Got it. All right, simplify this radical, or this fraction rather. Well, reduce, 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 that's the name of the game. 6 and 4 reduces to 3 and 2. So we have 3 and 2. 26 and 39, I can pull out a 13. 13 times 2 and 13 times 3. So now it's a much, much easier version of the same question. Reduce first or you won't be able to do these very efficiently. Nothing else reduces. I cannot break down any of the radicals. So I'm going to multiply this root 3 to the top. Again, this is a process I hope you can start doing in your head. I hope you try it every time you get to one. Root 3 times root 3 is whole number 3, so we have a 6 on bottom. And then we can reduce one more time. 3 and 6 is 1 and 2, so we have root 6 over 2 when it's all said and done. Reduce, simplify the radical, reduce, simplify the radical, keep reducing and simplifying the radical until you can't do it no more. All right, 45, 45, 90. On a 45, 45, 90, the leg times root 2 equals the hypotenuse. So I know the hypotenuse on this one, so the leg times root 2 equals 6 root 50. My hope is you can understand what to do quickly, just so we're very clear. You should be able to go from a hypotenuse to a leg in about 2 seconds once you get good at this. You should look at this like, oh, I need to divide by root 2 and just know the answer as quick as you can say it almost. But we have to divide by root 2 to cancel it out. This is a process, but again, I hope you're doing this in your head. Please try. That is 6 root 25. Well, the square root of 25 is 5. So this is 6 times 5, which would be 30. And that would be both of them since it's a 45, 45. So that is 30. We know this pattern. That's a pattern of 1 to 2. That means this has to be our root 3, so it has to be 7 root 3. That is a 30, 60, 90. If you see the pattern 1 to 2 from a leg to a hypotenuse, you need to recognize your 30, 60, 90 patterns. So this would have to be 7 root 3. I promise you, if you do a small version with 1 and 2, that'd be 2 squared minus 1 squared. It's the square root of 3. Multiply the 7 back in. I promise. I promise. All right, we talked about this earlier. First, we need to see, is it even a triangle? So 7 plus 2 is 9. Is 9 bigger than 9? No. So this one's not even a triangle. And I told you, on the quiz, if it is all whole numbers, you need to check if it's a triangle. If you have irrational numbers at all, you don't have to check. Now, in general, would you have to check? Yes, but I'm telling you on our quiz that if it has irrational numbers, it will work. So then you just got to go to step 2. Step 2 is squaring the numbers. So remember what squaring looks like. This is 5 root 7 times 5 root 7. That is like saying 5 squared times root 7 squared. That is 25 times 7. So that is 175. Here we have 9. So to square this would be 9 times 2, 18. And then square this, 12 times 12 is 144. So this is what we're working with. We add the two smallest numbers. 175 plus 18 would be 193. 193 is bigger than 144. That means c squared is, what did I just do? I just did something students do, because thank goodness I had the answer there. Let's take a step back. We add the two smallest numbers. They're not always in order. So it's 144 plus 18. Sorry about that. So that would be 162. And 162 is smaller than 175. C squared is bigger. And if c squared is bigger, it's obtuse. And then we have some fun numbers here. If you divide everything by root 2, that's a 5, 12, 13. But just for giggles, just to work it out, 13 times 2, 169 times 2 would be 200, 320, 338. 338. 5 root 2 square would be 25 times 2 would be 50. And 12 root 2 square would be 144 times 2 would be 288. Well, 288 plus 50 equals 338. And 338, oh goodness, is equal to 338. So it is a right triangle. But if you would recognize this as 13, 5, and 12, right, they all have a root 2 on it. Can you reduce? Absolutely. Reduce by a factor of root 2. That is a 5, 12, 13 triangle. Simplify. So multiplying and dividing, you're looking for the same idea. You're looking for common factors first. We can go ahead and do 6 times 7. So I guess we're looking for that first. But after you multiply the coefficients, what are your common factors? 9 times 2 and 9 times 7. So why do we do that? What is root 9 times root 9? That is whole number 9. So those are out, and then we have 7 times 2. We're looking for common factors or perfect square factors. There are no common factors, there are no perfect square factors, so we just multiply 7 times 2 back in. Got to do the 42 times 9. That would be 360 plus 18 would be 378. Wait. 360 plus 18 would be 378. Yes. Don't forget there's a root 14 on there. Got it. Perfect. Perfect. 45, 45, 90 rules. Remember that the leg times root 2. Oh, man. My L's. Leg times root 2 equals hypotenuse. This time we have the leg. So 9 root 22 times root 2 equals the hypotenuse. This is just the way I do it. I pull out the common factor first, right? 22 is 11 times 2. So what is root 2 times root 2? That's whole number 2. Times 9 would be 18, and there's a root 11 still. So 18 root 11 would be the answer. But to go from leg to hypotenuse, you multiply by root 2. To go from hypotenuse back to leg, you divide by root 2. Oh man, that's all of them. Lots of good practice here, guys. I hope you're actually trying to do these questions. You're not just copying answers. This is really important stuff, probably the most important stuff we learn in geometry. It's the most used after geometry. We need to know these processes. We need to know how to solve 30, 60, 90 triangles almost as fast as we see them. We need to know, is it times root 3? Divide by root 3. Is it times 2? Divide by 2. And then you need to know how to actually execute it. So we're going to practice. We're going to get good at it, but we don't have a lot of time. So make sure you're putting in the work. Love you guys. See you guys soon.